Welcome to Lesson 18, which roughly covers pages 112 to 117 of the Automate the Boring Stuff with Python textbook. This lesson covers the topic of data structures. Lists and dictionaries are powerful ways to organize data into structures that your programs can handle. For example, I could have a dictionary that stored information about a cat, say, store this in a variable called cat, and the dictionary just contains data describing my cat. Color gray. And this is kind of nice. Simplified version of my cat Zophie, but it's a version that a Python program could understand. I could also have a list of these dictionaries, say all cats, which starts off as a blank dictionary. I could call the append method, and then have a list with this dictionary. In fact, I could have a list of multiple of these dictionaries for all my various cats. Puka, who is 5 years old, has black fur, and Fat Tail, who is also age 5, who is gray, and that random stray cat that comes around the backyard. I don't know its age, I'll just put -1, orange. I actually don't have this many cats. Now, the all cats variable could be used in some cat-related program. This list of dictionaries is called a data structure. We can use data structures to model real-world things in a way that our programs can understand. So as an example, let's take a look at a tic-tac-toe program that I wrote. Here's the source code for it. It's just under 200 lines of code. When I run it, it looks like this. Do you want to be X or O? X. I'll just go in the top left. Mid right. Uh-oh, I'm kind of trapped here. I'll just block in the low middle section. And the computer has beaten you. Do you want to play again? No. So this is a really simple program, but how do we represent a tic-tac-toe board like this using lists and dictionaries and basically put it into a version that we could stuff it into a Python variable? And the answer is we use data structures to create a representation of this tic-tac-toe board. In this case, this is really simple. You can use string values to represent what's in each slot of the board. So X, 0, or a single space character. And so you'll need to store 9 strings for each of the 9 spaces. So we can use a dictionary of values for this. The X, O, and space can be the values, and the keys can be these strings for top left, top middle, top right, and then the middle row and the lower row. This dictionary is a data structure that represents a tic-tac-toe board. So let's store this in a variable named the board. So the board, and this will be a dictionary. We have a key that's top left, and that'll just start off as a single space to show that it's an empty space. It doesn't have X or O. And then top middle, top right, and I'm just going to copy and paste the rest of this. So here we have the board. We can go ahead and pretty print this as well using the preprint module. Oh, whoops, I accidentally set this X right here. I can change that. And set that back to a single space. There we go. So right now, this dictionary value, remember, Python just sees this as a dictionary with strings for keys and values for the key value pairs value. It doesn't actually see this as a tic-tac-toe board. I mean, it has no concept of this hashtag symbol drawn on a sheet of paper and people drawing zeros and X's and whatever. To Python, it's just a basic dictionary. But we can have our program use this to represent a tic-tac-toe board. So currently, this represents an empty tic-tac-toe board. All of these are just single empty spaces. But we could change this. Let's set that middle space back to an X. Equals X. Now when we print this out, everything's blank except for the X. So now this dictionary value, remember it's just a typical dictionary value, but our program can treat it as a tic-tac-toe board that looks like this with an X in the center. And we can keep changing around this dictionary to represent the board any way that we want. So let's just set the top to be all O's. And maybe we'll have the mid-left position be set to X. And also the lower right also be set to X. So now, this is what the dictionary looks like. And this dictionary value is a data structure for this tic-tac-toe board, in which we can see, oh, the O player has won the game because they have 3 in a row. So we'd have to write code that can recognize whenever there's 3 in a row inside this dictionary value. But remember, in the tic-tac-toe game, we didn't have just printing out this dictionary value. We had a nicer display right here, where it actually drew out a tic-tac-toe board for us. So how do we convert our dictionary into this output? And well, we can write a function for it. So this function can be print board, and it'll just take one of these tic-tac-toe dictionary data structures as the value for its parameter in board. And then we can just use a bunch of print statements to print out all those line characters, as well as the X's and O's. So here we'll print out the top row right here. So just print out whatever is in the top L position, and plus that vertical line. Another vertical line. And then the top right. And this will print out the first row. And we need that horizontal line. So 1, 2, 3, 4, 5. We'll need something to print out the middle row, which the code looks pretty similar, so I'll just copy and paste this and then change this to mid. Then we need another horizontal row and then the bottom row. So there we have it. This data structure for the tic-tac-toe board. We also have a function with code that treats that data structure and turns it into something that we humans can recognize. So when I call print board and I pass it this variable, the board, it'll print out that same tic-tac-toe board that we recognize. So this output can be as sophisticated as we want. We could have some fancy graphics if we had some sort of graphics library to do this fancy drawing and maybe make it 3D with lines that actually look like solid objects or anything like this. This is just using what we know, the print function to print out strings, to draw a simple tic-tac-toe board using these horizontal and vertical line characters from the keyboard. Because you created a data structure to represent a tic-tac-toe board and wrote code to interpret that data structure, you now have a program that models the tic-tac-toe board. This isn't a complete tic-tac-toe game, but you can see how a computer program can have a representation of something that just isn't a string or a simple integer. Lists and dictionaries allow you to combine and organize values to represent real-world objects. And last, let's learn about the type function. You can pass any value to the type function, and it'll tell you the data type of that value. This can be really helpful in the interactive shell when you need to identify what kind of value you're dealing with. So you can see send type the integer 42 and it replies with int, or I can pass it a string, or replace string, or a float, but then I could also pass it something like the board, and it says that's a dictionary. Oh, well, how about this value? And it'll say, oh, that's a string, so we can tell that the value at this key is a string value. So the type function, along with that pretty print function, are really handy to use in the interactive shell when you just need to see what data you have.